The question we are solving now belongs to test series 3. It is of control system subject. In specific, it belongs to MIMO control systems. As per the question, the state space representation of a control system is given as x dash is equal to 0, 1, minus 2, 0 multiplied by x and y is equal to 1 minus 1 x. It is given that the initial state of the control system is x of 0 is equal to 0, 1. We need to find the time response of this control system. Please note that here there is no input given to the control system. Hence, due to the initial state of the control system itself, there is some output which leads to the approach as shown. We know that the state response of the control system can be written as x of t is equal to phi of t multiplied by x of 0. Please note that the state response we have written here corresponds to the response due to the initial conditions only. Here, phi of t can be written as L inverse of Si minus A whole inverse. We can write the term Si minus A whole inverse as S minus 1 to S inverse. And upon obtaining the inverse of this matrix, we see that Si minus A whole inverse is equal to 1 by S square plus 2 S 1 minus 2 S. So now from this we see that we got actually Si minus A whole inverse. For getting the term phi of t, we need to find the inverse Laplace transform of Si minus A whole inverse, which is equal to L inverse of S by S square plus 2, 1 by S square plus 2, minus 2 by S square plus 2, and S by S square plus 2. So here phi of t is equal to the inverse Laplace transform of each of these individual terms. We know that Laplace transform of cos omega t is equal to S by S square plus omega square. We also know that Laplace transform of sin omega t is equal to omega divided by S square plus omega square. So from this data we see that phi of t is equal to cos of root 2t 1 by root 2 sin root 2t minus root 2 sin root 2t and cos of root 2t. So we have phi of t and we are given x of 0. From this, the state response due to the initial condition can be written as x of t is equal to phi of t multiplied by x of 0, which can be obtained as 1 by root 2 sin root 2t and cos of root 2t. So this is obtained by multiplying phi of t with x of 0 given. But we need to find the time response of the system, which is written as y of t is equal to x1 of t minus x2 of t, because y of t is multiplication of 1 minus 1 and the state vector x. So which can be further simplified as 1 by root 2 sin root 2t minus cos root 2t. So this is the response of the control system due to the initial condition, and it is obtained from the state response. Hence, as none of the options given, that is A, B, C, correspond to this answer, the correct option representing the output of the MIMO control system is D, which says the solution obtained is none of the options.